Hey guys, welcome back to another geometry video. Last time we started work on inequalities and we ended off with addition inequality and subtraction inequality. So before we go into multiplication and division, we're just going to review what those were. So inequality with addition, so if equal quantities are added to unequal quantities, then the sums are unequal in the same order. So for example, since 12 is greater than 5, then if you add the same number to 12 and 5, then the quantities will be unequal in the same order. So 12 plus 3 is still greater than 5 plus 3. And for subtraction, it's basically the same thing. If equal quantities are subtracted from unequal quantities, then the differences are unequal in the same order. So if 5 is greater than 2 and you subtract unequal quantities, if you subtract equal quantities, then the differences are unequal in the same order. So this is a proof using what we learned last week, just to refresh our memories. So it gives us that the measure of angle BDE is less than the measure of angle CDA, and it asks to prove that the measure of angle BDC is less than the measure of angle EDA. So with the information we're given, we can say that the measure of angle BDE plus the measure of angle EDC is less than the measure of angle EDC plus the measure of angle CDA. And this is because of what we learned about inequalities with addition. So if equal quantities are added to unequal quantities, then the sums are unequal in the same order. Next, we can say that measure of angle BDC is equal to the measure of angle BDE plus the measure of angle EDC. And this is because the partition postulate, which basically says that a whole is equal to the sum of its parts. And with this partition postulate, we can also say that the measure of angle EDA equals the measure of angle EDC plus the measure of angle CDA. So finally, we can say that the measure of angle BDC is less than the measure of angle EDA, and that's because of the substitution postulate. You can substitute quantities that are unequal in the same manner into different inequalities. So we learned about addition and subtraction, so we're going to move on to inequalities with multiplication and division. So for multiplication, if unequal quantities are multiplied by positive equal quantities, then the products are unequal in the same order. But with negative quantities, so if unequal quantities are multiplied by negative equal quantities, then the products are unequal in the opposite order. So, for example, say we have 9 is greater than 3, then if you multiply them both by 4, which is a positive number, then the inequality stays in the same order. But say you have so I think my connection got cut off, but as I was saying, if we multiply both sides of the inequality by a negative number, so say negative 4, then the sign changes from a greater than sign to a less than sign. So they're unequal in the opposite order. For division, if unequal quantities are divided by positive equal quantities, then the quotients are unequal in the same order. But if the quantities are divided by negative equal numbers, then the quotients will actually be unequal in the opposite order. If unequal quantities are divided by negative equal quantities, then the quotients are unequal in the opposite order. So for example, if we have 9 is greater than 3 and we divide it by a positive equal number, for example 3, so 9 divided by 3 and 3 divided by 3, the sign stays the same. It's in the same order because we divided by a positive number. But if we divide by a negative number, then so 9 divided by a negative 3 and a 3 divided by a negative 3, then the sign flips, so they are unequal in the opposite order. So here we have a proof, and we're given that the measure of BA equals 3 times the measure of BD, the measure of BC equals 3 times the measure of BE, and the measure of BE is greater than the measure of BD. What we have to prove is that the measure of BC is greater than the measure of BA. So with what we're given, we can first say that 3 times BE is greater than 3 times BD. And this is because of what we just learned about multiplication. So, multiplication, inequality. Basically, if unequal quantities are multiplied by positive equal quantities, then the products are unequal in the same order. So, we know that BE is greater than BD, and we're just multiplying both sides by 3, which is positive. So the greater than sign stays the same. Next, we can say that we can actually go ahead and prove it. BC is greater than BA, and this is because of the substitution postulate. So we know that 3 times BE is greater than 3 times BD, but we also know that 3 times BE is equal to BC, and 3 times BD is equal to BA. So we can substitute BA for 3 times BD, and BC for 3 times BE, and we get that the measure of BC is greater than the measure of BA. So our next theorem has to do with triangles and inequality within triangles. So the triangle inequality theorem states that the length of one side of a triangle is less than the sum of the lengths of the other two sides. So in this triangle ABC, basically AB is less than AC plus CB. BC is less than BA plus AC, and AC is less than AB plus BC. So every single side is less than the sum of the other two sides. So here we're given 4 different possible combinations of side lengths for triangles, and we're going to figure out which combination is the only possible one for sure. So what we just learned was that a single side of a triangle has to be less than the sum of the other sides. So what we can do is just test that out by adding two sides and comparing it to the greatest length of all three sides. So what that means is, for this particular combination, we have to see if 10 is less than the sum of the other sides, 4 plus 6. And that's incorrect because 4 plus 6 equals 10, and that means 10 is not less than the sum of both sides. For this combination, 16 is less than 8 plus 8. That's also incorrect because 8 plus 8 is 16. For this one, 16 is less than 6 plus 8. Well, 6 plus 8 is 14, and 14 is actually less than 16, so 16 is greater than 14, so this is also incorrect because we're trying to find sides that are less than the sum of the other two sides, not greater. And then finally we have this, 14 is less than 10 plus 12. Well, that's correct because 14 is less than 22. So that actually goes hand in hand with what we just learned, the triangle inequality theorem, which states that the length of one side of a triangle is less than the sum of the lengths of the other two sides. So in this combination of sides, 14, which is a side on the triangle, is less than the sum of the other two sides. So only this combination of sides can make an actual triangle. Here we have another proof. It gives us that the isosceles triangle ABC, with AB, the measure of AB equaling the measure of CB, and it gives us the midpoint M right here of the line AC. And it asks us to prove that the measure of AM is less than the measure of AB. So with what we're given, we can first say that AC is less than AB plus CB, and that's triangle inequality. Triangle inequality. And from there we can say that AC is less than 2AB through substitution, because we know that AB and CB are equal in length because it's an isosceles triangle. So this is substitution. Next we can use the definition of a midpoint to say that the measure of AM is equal to the measure of MC, because a midpoint splits a line segment into two congruent parts. And with the partition postulate, we can say that AC equals AM plus MC, because a whole is equal to the sum of its parts. Next we can substitute again, because we know that AM is equal to MC, so we can say that AC is equal to 2AM through substitution again. And we're only allowed to substitute because we know that AM equals MC, just like how we knew that AB equaled CB. And then we can say that 2AM is less than 2AB because we know that AC equals 2AM and we know that AC is less than 2AB, so through substitution we can say that 2AM, which is equal to AC, is less than 2AB. So that's substitution again. And finally, we can conclude that AM is less than AB. And this is the division postulate of inequality. Inequality. So basically, what we did was divide by a positive number on both sides. And if you remember, dividing unequal quantities with a positive equal quantity does not change the order of the inequality. So AM is less than AB, and that's the final proof. So exterior angles, or exterior angle of a polygon, is basically an angle that forms a linear pair with one of the interior angles of a polygon. So what that means is that, say we want to create an exterior angle at the interior angle A. So the interior angle A is this angle over here. And in order to create an exterior angle, we have to form a linear pair with that angle, meaning we have to extend the line AD outwards like this, and this creates another angle right here, which is an exterior angle of that polygon at the interior angle A. So say this is ray AE. So ray AE had to be drawn coming off of this interior angle to create this exterior angle. And that can be done with any interior angle on a polygon. So we could have done it with CB, the side CB on interior angle B. We could have extended this, creating a linear pair. So the interior angle B is right here, and once we extend it, this angle becomes the exterior angle because we drew a ray BF from the interior angle. So the exterior angle inequality theorem goes hand in hand with that, and it basically means that the measure of an exterior angle of a triangle is greater than the measure of either non-adjacent interior angle. So what that means is that, let me just write the definition first. The measure of an exterior angle is greater than the measure of either non-adjacent interior angle. And to explain that in simpler terms, let's say we have the exterior angle DAC right here. This angle will actually be greater than the angle ABC right here and the angle BCA over here. So these angles that are marked in red, these angles are non-adjacent interior angles, meaning that they are not close to the exterior angle here. The only adjacent interior angle for the angle DAC would be the angle CAB over here. So this theorem basically says that for any exterior angle, for example DAC, this angle measure will be greater than both the angles that are not next to it, both interior angles that are non-adjacent. And let's say we chose a different exterior angle. Let's say we chose FCB, right? So then the non-adjacent interior angles would become these two here, which are CAB and ABC. And the adjacent interior angle would be right next to it, BCA. So angle FCB would be greater than both this angle and this angle because they're non-adjacent interior angles. We're going to stop here today and continue on next week. So thank you for tuning in, and I'll see you later.